Alright guys, so notes for 2.5. This is our library of functions, which means all the functions that you should know and basically have memorized in your head, and some of them you definitely know. Like, you know what an absolute value function looks like. You know what y equals x looks like. It's that perfect diagonal, right? You know what a square function looks like, right? X squared. What you might not remember is a square root function. You should know by the end of, let's say, this weekend, that it starts at some point and then it just kind of swoops like that. Okay, so depending on the actual function, this is the square root of x, so it starts at 0, and then if you were to plug in 1, you get 1. If you were to plug in 4, you would get 2, right? Because the square root of 4 is 2. Okay, so in the beginning, it's just talking about, over here is talking about for a constant function, so like y equals 5 or whatever, what would the x-intercept be? So I said usually there's no intercept, okay? So I said usually none. And then what would the y-intercept be? Well, it would be 0, comma, and then whatever c is. If this was x equals, this looks like x equals, 1.2 or whatever. So then this would be 0, comma, 1.2, right? So I said 0, comma, c. Is this an even or odd function? Well, if you look at it, doesn't it fold onto the y-axis? So I said an even function. Does it increase? I left it blank. No. Does it decrease? No. This is really where does it increase, where does it decrease? But it doesn't because it's a horizontal line. Where is it constant? So it's a constant slope, and then it goes all the way from negative to positive infinity. What about maxes and mins? Nope, no max and min. What about domain and range? So I said the domain goes from left to right all the way, negative infinity to positive infinity. Remember, domain and range always have solution sets. The range here is just the y value, c, right? That's it. So for all of these, I don't really necessarily want you to copy all of these, but I do want you to check them, and then I want you to do the ones on the bottom as well, okay? I'm going to talk about a round down function, so I do want you to highlight a little bit. So this one right here, the round down function, the greatest integer function, the name is either one, okay? We also call it a step function because look what it looks like. It looks like a bunch of steps, right? So I'm going to explain how come it's a step function, why is it called a round down function, but go ahead and highlight, and then also go ahead and write that this is also called a round down function, which is really helpful when you're drawing it. And then on the right side, this shows that this can be written, I'm going to write it over here also. It can be written as y equals, and then it's maybe a double bracket, or it's y equals, sometimes you're going to see a single bracket. This is not the same as absolute value though, okay? Or you'll see y equals, and then it's an int. So that stands for integer. So integer function. All of these mean the same thing. When you see this on a quiz, when you see this on a test, when you see this on a pop quiz, you're supposed to know what it means. So when you raise your hand and ask me, is that an absolute value function? What is that? I can't tell you on a test, but like on a regular day, I'll be like, oh, that's the step function, okay? All right, so how come it's called a step function? Why is it called a round down function? Why do I think that's so great when you call it a round down function? Okay. So basically, so here's a little I just wanted to show you how come, okay? So basically what this means is whatever you plug in, you round it down and that's your answer. So like 1 rounds down to 1. So if you plug in 1, you get 1. 1.5 rounds down to 1. So if you plug in 1.5, you get 1. If you plug in 1.9, you get 1. If you plug in 1.99, you get 1. So what happens is, let's say you start with 0. So 0 rounds down to 0. Here's my point, 0, 0. If I have 0.5, it rounds down to 0. So I still am here. I would draw like another point and another point and another point and another point. And then I get to 0.99999, it rounds down to 0. And it rounds down to 0 until we literally get to 1. That's our next integer. So at 1, it all of a sudden jumps up to 1. So 1, comma 1. Well, what happens here? It's basically a line until here, and then there's a hole. And then it jumps up to here. And then the same thing happens. You plug in 1, you get 1. You plug in 1.1, you get 1. You plug in 1.2, you get 1. You plug in 1.5, you get 1. You plug in 1.9, you get 1. And then at 2, all of a sudden it jumps to 2. So then you get that. And then it just continues, and that's why it looks like steps. That's why it's called a step function. Okay? So the first thing is to cover or stop this, and then you're going to go ahead and make sure your answers make sense. And then you're going to pause, and you're going to pause it now. And then after you pause it, did you actually pause it? You're going to go ahead and check the bottom ones, okay? Make sure that you're not just copying, because you have to be able to like understand. I want you to think of it on your own. So it will take a little bit of time, right? Okay. And then just as a reminder, a reciprocal function is 1 over x. So these you tend not to remember until like now, okay? But square root function versus a cube function. So this is how I remember a cube function. X cubed looks like x squared, except the other side goes down. So that's how, like, honestly, that's how I remember x cubed, okay? A reciprocal function, 1 over x, is 2 asymptotes. So you have an asymptote here, horizontal asymptote, a vertical asymptote here, and then you have your hyperbola. Hyperbola, there you go, okay? It's a hyperbola. So then kind of check your answers down here, and then if you have any questions, we can talk about it when we see each other again. And then there's one that I forgot here, which is a cube root function. You should generally know what that looks like, and it's so easy to guess what it looks like. A cube root function goes like this, and then the other side just goes the other way. So it's kind of like that S shape, like this, but like swooped the other way, okay? So I have it right here on the back. So see, on the back. So go ahead and jot that down. This is a cube root function. It looks something like that, just as a reminder. I forgot to put it in, so we're just putting it there. Okay? Okay. I'm going to remind you, for example 1, how to graph a piecewise function. So a piecewise function, this is what I like to do. Oh, by the way, add in a -1. I want to change this a little bit. Add in a -1, okay? So what I like to do for a piecewise function is I like to name my pieces. So I'm going to say this is piece 1, this is piece 2, this is piece 3. Okay? So I like to do that before I graph anything, or before I even like work on the problem sometimes. So the first couple are kind of simple. So it says f of -7. Where is -7? -7 is to the left of -4, but literally x is only, so in piece 1, it's only between -4 and -1. And then it goes on to 2, and then it goes on past 2. But there's nothing before -4, see? So then that means that f of -7 does not exist. Or you can just say no solution. Both are fine. Can you try to answer the other ones? Come on, just do it. And then I'll show you. Do it. Pause. Okay. And then this is in piece 1, right? It's between -4 and -1, so you just plug it in and you get -1. And then 2 is right here between -1 and 2 because this has an equals. So then you plug it in, and then there's nothing to plug in. Oh, so your answer is 5. Okay, so any number between -1 and 2, inclusive of 2, is going to be 5. All right. And then 4, where's 4? 4 is to the right of 2, so I plug it into here. 4 squared minus 1 is 16 minus 1, which is 15. Okay, now we're going to draw it. So you have to be able to draw these piecewise functions as well. So the first thing I do, actually, when I graph, I'm going to block this a little bit. The first thing I do when I graph is I go ahead and draw my breaks. So I call these my breaks. Where are my breaks? My breaks are at -4, -1, 2. Those are my x value breaks in my graph. So my x value breaks in my graph, I would draw first with a highlighter, and I would go to -4 on the x-axis, and then -1, and then 2. I'll label it. So here's my -4, here's my -1, and here's my 2. So I draw these breaks because I want to tell myself that between -4 and -1 is piece 1. So that's this line. So then over here, I put a 1, and then I put, this is piece 2, this is piece 3. So piece 1 has to be over here. Piece 2 has to be between. Piece 3 has to be past that last break. So that's what the breaks help me with, okay? How do I draw it? Well, 2x plus 3. 2x plus 3 has a y-intercept of 3 and then a slope of 2. So normally I would go up 2 to the right 1. I can't draw here. I can do it very lightly with a pencil. And I keep going all the way across my graph. And then basically I erase everywhere that it's not supposed to be. Where is it supposed to be? It's supposed to be between -4 and 1. It's supposed to be only between this highlight and this highlight. That's it. That is my piece 1. My piece 2 says y equals 5. Y equals 5 is a horizontal line. Right here it says open circle basically and closed circle. So here's my open circle all the way to my closed circle. What does this look like? This is a perfect parabola, but shifted down 1. And it's after x equals 2. So after x equals 2, after this, I should have a parabola, but I'm going to start drawing it here lightly with the pencil, and then I'm going to erase. So a parabola normally goes to 1, 1, and then to 2, 4. But then it says -1, x squared minus 1, so then it went down. So then my parabola, if I were to like imagine it, goes like this. And I can draw this last piece because this is part 3. So this has to be past x is greater than 2. So I can only draw it over here. I can't draw the rest of it. If I do, I have to erase it later. Okay, this is your piecewise function. Okay, so I know you could see all the answers over here also, but I want you to fill it out. I want you to pause, and then unpause, and then check your answers. Okay, ask me about these later if you're not sure how come. I didn't put anything here because it's never decreasing, right? There's no like part where the slope is negative. Okay. Greatest integer functions. On the right side, I want you to write some things down. So I want you to write right here. What is the greatest integer of 0.1? We just talked about it. Round down, what do you get? Round down 0.99. What do you get? Round down -1.3. What do you get? Be careful here. What's -1.3 rounded down? That's to the left. What is pi rounded down? What is -pi rounded down? I want you to write an answer, and if you're wrong, that's okay. You can fix it. There's whiteout and there's eraser. Don't just copy me. Okay, I'm going to show you. Did you get these as your answer? Did you maybe get this wrong? Because if you put -1, -1 is bigger than -1.3. You have to round down. That's to the left on the x-axis. That would be -2. 3.14 rounded down is 3. Negative 3.14 rounded down is not -3. That's bigger than -3.14. It's -4. And I say 3.14, but it's really like 3.14 da 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 da, right? Okay. Now we're going to draw. Okay. So how you're going to draw is you're going to realize that this, so you learned this in Algebra 2. I know you did. So this next to the x is a horizontal portion, okay? So if it was vertical, it wouldn't be like with the x in parentheses, okay? So this is a horizontal portion. You have to remember x's lie. X's are big fat liars. Your ex-boyfriend, your ex-girlfriend, we think you're not the liar, right? They're the liar. X is lie. So it says 1/2, but really the horizontal stretch is 2x. So what I do is, before I graph it, I do this, and I do my x and y chart, and I just do a few. I just do, like, I start from negative, you can start from -2 all the way to 2, but I did -1 all the way to 2, okay? So if you plug that in and you round down, you get the same thing. But then what I do is I do that horizontal stretch. So everything in the horizontal, I times 2. Write this down. Don't just like copy the important parts. Copy everything. Okay, so because I'm multiplying all the x values by 2, I multiply them all by 2, and then I cross out the ones that I don't need anymore. Don't cross it out like a crazy person, like a madman. Just like a little bit of a slash, okay? Now I have my new x values and my new y values. How you draw that, yes, looks like that, but I want to show you how I would draw that, okay? So I'm going to show you. So 1, 2, 3, 1, 2, 3, and then just in case, some on the left. Okay, so this is how you do it. You start with the first point that you have, which is -2, -1. Your next point is 0, 0. This tells me that I'm going to the right. My step goes to the right, and then here's my hole. And then my next point is 2, 1. So 2, 1. And again, I go to the right, open. I go to the right, open. And then you can just follow that pattern all the way to the other side also. So that's why my graph looks like that. So draw yourself a little XY, and it should look like that. Okay. And then I think you should really try this one on your own, because you know what that looks like, and then plus 2, what does that look like? But I'm going to show you right here that this is, remember, this is a vertical shift of 2, so all the y values go up. So I did my xy, and then I added 2 to all my y values. And then my first point, my second point, I draw my step. And then I draw my next point, I draw my step. And it's going to look something like that, right? So always label, I don't know why this is not labeled, always label at least one x and one y. Always label at least one x and one y, okay? Okay, the last one, you should know this still means greatest integer function. So this greatest integer function, what does this mean? This parentheses means the 2 is with the x. What do x's do? Man, they're big fat liars. So x is not actually going to the right, x is going to the left. It's a horizontal shift of x minus 2. Okay, when you do your little xy chart, does that work? When you do your little xy chart, you start the same way, and then you go, okay, I'm supposed to go minus 2. So you minus 2, minus 2, minus 2, minus 2, cross, cross, cross. You draw your first point, draw your second point, make sure you're going in that direction of your second point to draw your step. And then after you've done it, you're going to check, because you're not just going to copy me, because you can't do that on a test or a quiz or homework, right? You have to like actually do it. Okay, so stop lecturing me, Miss Yan. All right, so go ahead and check, and then if you have questions, then you can ask them the next time we see each other. You can also put them in the comments, and I'll try to answer that as well, okay? All right, good luck. I'll see you soon.